Good morning, everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Together we strive for a change through education. Ladies and gentlemen, I want to take you through the complex numbers. This is the mathematics topic. Particularly, my target audience are the university students, the first year university candidates, and also those candidates who are at the TVET colleges, who are actually doing what you call the NCVs, or who are actually doing the NATED programs or the NATED courses. NCVs, which are the National Certificate Vocational, particularly those students who are doing mathematics, being at the college, the TVET colleges, who are actually doing maybe level 2, level 3, but actually the focus is level 3 and level 4s. And also those who are doing the NATED, particularly doing mathematics, most of them who are doing engineering, those who are doing engineering, whether they're doing electrical engineering, mechanical engineering, and also those who are doing the millwrights. These are it is the relevant topic for those candidates, and also the first year university candidates who are actually in the field of engineering, but not necessarily in the field of engineering, but as long as you are doing your first year and you'll be doing maths, then this is also one of the relevant topic for you, ladies and gentlemen. So if you are a YouTuber, or you just watch this is the first time of you watching my YouTube videos, kindly follow the YouTube channel that I've provided here. You can just type Kangaroo Maths and Science Academy on the YouTube platform, then you'd be able to see all the videos that I've already created. Ladies and gentlemen, don't forget to like, subscribe, and hit the bell notification for future videos update. Without further ado, ladies and gentlemen, let's now start with the learning outcomes. Right. At the end of the session, one must be able to actually understand the standard form of a rectangular, which is a complex number, and also be able to represent the complex number in something called an Argand diagram. We'll talk about this. And also you need to be able to solve problems using complex numbers, and also be able to find something called the conjugate of a complex number, actually in a rectangular form. Ladies and gentlemen, there are two types of complex numbers. There are two types of complex number which we'll talk about, but in this session, we will focus more on what you call the rectangular form. Right, first of all, we need to actually understand what do we mean by a complex number. Right, actually a complex number, ladies and gentlemen, it is just a number system. It's a number system that actually, I apologize, it's a number system that comprise of the real number, apologies guys, that comprises of the real number, the real numbers, and actually the real and imaginary numbers. So that comprises of the real and the imaginary numbers. In other book, we can call it a non-real numbers, the imaginary numbers. So it means these complex numbers actually incorporate the relationship between the real number and the imaginary number. It's just a number system that comprises of the real and the imaginary numbers, right? But now, actually, what do we mean by these complex numbers? Okay, let me just do one simple example. Imagine, ladies and gentlemen, when you are in grade 12 or in grade 11 or grade 10, if we said to you, find the roots of, for example, let's say x squared plus x plus 1 equals to 0. Let's say you are given this kind of equation and you are asked to determine the roots of this equation. Remember, we know the roots are just the values of x that will satisfy this equation. So now, algebraically, we'll say, by looking at this equation, you can easily see that this equation is not factorizable. So if we were to solve this, we are going to say x equals to minus b plus or minus the root of, we use a quadratic formula, b squared minus 4ac divided by 2a. By looking at this, already we know this is in a standard form. The b will be 1 plus or minus. The b is the coefficient of x, it's 1 minus 4 into the a, it's also 1 here. And the c, it's 1. Then everything divided by 2 times 1. Then let's solve for x here. This would be x equals to minus 1 plus or minus the root of, let's work out the expression inside the root sign. This will be 1 minus 4 times, which is just minus 3 over 2. And honestly speaking, because of this negative number inside the root sign, in the lower grade, we'll say there will be no solution. There will be no solution. Why? Because we know that the square root of a negative number, it's always non-real. Does not exist. It's non-real. Because now we know under the types of numbers, we know that we have numbers that are actually real and those numbers that are non-real. The numbers that are actually real are those that can be found on the number line from negative infinity to positive infinity. But numbers like the square root of a negative number, this is an example of a non-real. So now it means that if we were in grade 12 or the lower grade, we'll say there will be no solution. Because why? This is a non-real root. This is a non-real root. Remember, another way, if we do not want to solve this algebraically, we can either use the nature of roots to actually know more about the discriminant. To say discriminant is b squared minus 4ac. Look at this, because this one is going to give us whatever it's inside the root sign, which is negative 3. You see that the discriminant is less than 0. We know that when discriminant is less than 0, the roots are non-real. So which means that when you are in grade, in the lower, like in grade 12, you'll say there is no solution. But under the context of complex numbers, we cannot say there is no solution. There is a solution when we are using complex numbers. So it means complex numbers actually extend this number system from being real, like it extended the number system by incorporating the real and the imaginary numbers. To say now we can say, because we've seen that this equation has no solution, then now we extend this number system of real numbers to incorporate the non-real number. And this is actually called the complex numbers. So it means that in the context of complex number, we will say there is a solution. And what will be the solution? It means now we have to continue with this number, the solving, to say from the x that is equals to -1 plus or minus the root of -3 divide by 2. Then we can conclude to say, oh, I apologize. We can simplify this and say, now we have x equals to -1 plus the root of -3 over 2, or x equals to -1 minus the root of -3 over 2. Then now we need to continue and say, okay, fine. We have to simplify this expression. We have to simplify expression. So it means we will no longer say there is no solution. There is a solution now because we are now introducing the complex numbers. So now let's now simplify this. This will become x equals to -1 divided by 2 plus the root of -3 divided by 2. I believe you're following. Or we can still say x equals to -1 divided by 2 minus the root of -3 divided by 2. Then we'll have to expand this to say the square root of -3, ladies and gentlemen. The root of -3, by using the surds, this can be written as 3 multiplied by -1. And we know that the square root of a times b, this is the square root of a times the square root of b. Then this will become the root of 3 multiplied by the root of -1. So it means from now on, we can say, according to the complex numbers, they denote this root of -1 to be equals to I. In other book, they use I or J. Either they use I or J, but in this context, I will use the I. So which means that we can rewrite this to say, this is the same as the square root of 3 times I. Then it means to simplify this equation, we'll say we have x equals to -half plus the root of 3 multiplied by I divided by 2, or x equals to -half minus the root of 3 over 2I. Then now this is actually called a complex number. So which means that under the complex number, we have incorporated the real numbers, the real number, and the non-real number. So it means a complex number actually comprises of the real part and the non-real part. And this non-real part is called the imaginary number. And this is actually called a complex number. So now it means that we now understand what is it called, what is a complex number called, right? Then now it means then we can continue and say, we can now say wherever we have a real number, a complex number can be written in a standard form of, let me write a standard form of a complex number. So it means the standard form of a complex number is x equals to a plus b j. Oh, let me use I here. It's either we use j or we use I interchangeably, so there's no problem with that. So, but for this one, I'll use the I. So which means this is called a complex number. And within this complex number, remember we said the I is the square root of -1. So it is that we use the I or the j, because, for example, if we have the root of -8, this will be the root of 8 multiplied by the root of -1, which is just the root of 8i, which is the root of 8i, which you can also write it as 2 root 2i. I apologize. 2 root 2i, 2 root 2i. So the root 2i. So which means that within this, because we call these a complex number, the name of this complex number is called a rectangular form. This is the type of a complex number. So this is in a rectangular form. So it means in this video, in this session, we will only address the complex numbers that are in a rectangular form. And within these complex numbers that are in a rectangular form, the a here is called the real part. This is the real value. This is the real part. And the b here is called the imaginary part. This is the imaginary part. And this is the imaginary part. So we have the real part and we have the imaginary part. Hence, I said a complex number, it is a number system that comprises of real and the non-real number. So this is the non-real or the imaginary part. So it's very important to be able to know which one is the real and which one is the non-real. So it means from what we have solved here, you can easily see that a -half will be the real part, and the plus or minus the root of 3/2, this will be the imaginary part. So now we are able to represent or to solve for the complex numbers. Right, there are two types of complex number, but in this session, I'll talk about the rectangular. So we have something called a rectangular and what is called the polar form. There is a rectangular form and there is also what is called a polar form. This is one of the topics that you need to understand, particularly for students who are at the TVET colleges. You need to be able to know this, because I know, because I was once a lecturer at Waterbeck TVET College for 5 years. So I know these things. I've taught them for quite some while. So make sure that you understand, ladies and gentlemen. Right. Now, again, we have now addressed the standard form of a rectangular form. We explained what is a complex number. Now I want us to explain how to represent the complex number in a diagram called the Argand diagram. In a diagram called the Argand diagram. Right, let's now move on to the subtopic. So now I want us to talk about an Argand diagram. Right, an Argand diagram is just a Cartesian plane, that is used when you are dealing with complex numbers. It's a Cartesian plane that is used under complex numbers. We know, ladies and gentlemen, okay? Let me just try to move this, okay? Right, imagine we have the following Cartesian plane. Let me try to draw it. Okay, let me try to draw it. Imagine we have the following. I'll just represent the positive one only. Okay, fine. So let's say we have the following Cartesian plane. Within this Cartesian plane, this is called the y-axis, and this is the x. This is the Cartesian plane that we know. But the Cartesian plane that is used under complex number, it's called an Argand diagram. I want you guys to listen to me very well. This Argand diagram, the x-axis of this Cartesian plane on an Argand diagram, it only represents the real values. So this is the real axis. So it means we only include the real values. So this is the real axis. it is the real x. So it means it's where we represent the real values. Let me just use, it's where we only represent the real values. So we put the real values. So this is the real x, the real axis. And this is actually the y-axis is called the imaginary axis. So we have the real axis and we have the imaginary axis. So I'll just write I or I am. So this is the imaginary axis and the real axis. So it means within this Argand diagram, we can represent our complex number. For example, let's assume we are given the following. It's just an example. Let's assume we know the following. We know that, for example, I'll just call, I will use symbol Z to represent a complex number. So I'll just use Z to represent a complex number. So if I say Z equals to 3 plus 2i, let me just say 2i. So you need to know the standard form of that complex number. Already by looking at this complex number, it is in a rectangular form. This is the rectangular form of a complex number. And this rectangular form, this is the real part. And this one, it is the imaginary part. So which means if we want to represent these on the number line, we must look at the real part. The real part, let's say this is 3 there. And the imaginary will be on the y-axis. Let's just say it's 2 somewhere. It's just an example. So we're going to look at their intersection. So this is the point of the intersection. Then it means we'll have to draw the line from the origin to the point of contact of the two, like to the point where the two coordinates, the x and the y has met. So this is actually our Argand diagram, but still we are not done. We need to write an angle, which we'll talk about it later, which we'll call it an argument. So it means from the origin to this point, this is called the R. Is called the R. We'll talk about this. And to represent the angle, it means we represent it from the positive real x-axis up until it touches the line. So this is the angle of interest. So which we'll talk about this. And this R here, the R here, and the theta here, we'll talk about it in the next part. The R is called the modulus. It's called the modulus, whereas the theta is called an argument. It's called an argument. And we can determine these by using any scientific calculator. But for now, I'm not going to address it. I just want to show you how to actually represent these on an Argand diagram. So this is the Argand diagram where we represented the complex number. The Argand diagram where we represented the complex number. So which means you know that if remember this is the A and this is the B. If both the A and the B are positive, it means they'll be in the first quadrant. Imagine when we have this, let's say we have something like this. Let me just try to change this. Let's say we have the following. We have Z. Let's call this Z1. Let's call this Z2. Let's say we have -3 plus, just an example, -3 plus 4i. So you need to be able to know which one it is the real. This is the real. And this one, it is the imaginary part. So it means to represent these on an Argand diagram, we can still edit here or we construct another one. Let's just try to construct another one here. Remember I said the x-axis is the real part and the y-axis is the imaginary part. So it means now we'll say there it's my A. Remember, this is the A, this is the B. The A, it's -3, then the B, it's 4. Then we're gonna look at their point of the point of where they're intersecting is here. So we'll draw a line from the x-axis, from the origin up until to where they meet. So this actually represent the modulus, the R. But how do we represent the angle? Remember, in mathematics, we always measure angles anti-clockwise if you want them to be positive. So it means what you have learned under trigonometry. So from the x-axis, from the real axis, we draw the angle, the argument actually. So you see that this angle is already bigger than 90. It's bigger than 90. So it's an obtuse. It's an obtuse. So this is the argument. So sometimes it's very important to be able to represent your complex number on an Argand diagram. We'll talk more about this. So it means we'll talk about something called the polar form. So it means the polar form of a complex number requires this modulus and this argument. Guys, this is one of the easiest, and it has a lot of marks, particularly for the TVET college candidates. Very important, ladies and gentlemen. You can score a lot of marks only when you understand the things that I'm actually explaining to you. So now you are able to know what is a complex number, how we'll also be able to represent a complex number using a rectangular form on an Argand diagram. So now I want us to solve problems that are relating to complex numbers, ladies and gentlemen. So we can come up with other methods, but for now, I want us to talk about this. In part 2, I'll talk about the polar form and actually how to convert from rectangular to polar, and also from polar to rectangular, how to deal with something called De Moivre's theorem. We'll talk about that, but that will be part 2 session, ladies and gentlemen. All right, let's move on. Let's move on and talk about the addition, subtraction, and multiplication of complex numbers. Addition and subtraction, and also multiplication of complex numbers. Let me start with the addition, particularly those that are in a rectangular form. We know that the ones that are in rectangular form, they're in the form of a plus bi, or the j. By the way, guys, the I is the square root of -1. And no, if the I is the root of -1, how about the I squared? Obviously, the I squared means, to make I squared means we have to square both sides to remove. So this will be the root of -1 squared. This will be -1. So how about I cubic? So the I cubic will be what? It will be the I multiplied by the I squared, which will just be the I into, what is the I squared? The I squared is -1, which will give us the -1. So how about the I to the power 4? The I to the power 4 is the root of -1 to the power 4, which will just be the same as 1. The same as 1. Okay, I apologize, guys. I apologize here. The answer here is 1, not -1. I apologize. But now, how about I to the power of 5? I to the power 5 is the same as I multiplied by I to the power 4, which will just I times 1. And this will just give me, oh, okay. No. I apologize here, guys. I apologize. I don't know what is here. Okay, I apologize, guys. I think even here it should be 1. Not I think. So it means now we're gonna have the following. So we have the I squared, it's 1. So it means this become I. then this one it's like +1. Why? Because remember the I squared multiplied by I squared. The I squared, this gives us, oh, okay, guys, I apologize. What's going on with me? I apologize because the square root of -1 times the square root of -1, this gives me -1. Yes, so this is -1. Why am I incurring a lot of mistakes? Okay, fine. So this is -I, then this would be the I squared, which will be 1. Then now, because look, this is I squared multiplied by I squared. So the I squared is -1 and it's -1. Then this gives us 1. Then how about this? This will be the I times the I to the power of, so this would be 1. So it means the answer becomes the I. What's going on with me? Okay, let me just do my working well. Okay, remember we know that when we have the root of 2, and if you square this gives us 2. Then how about when we have the root of -2, we multiply by the root of -2, this becomes -2, right? Which means that when we have the square root of the I squared, it means now we are squaring the root of -1. So it's the root of -1 squared. We're just removing, so this will be -1. But now, how about I cubic? I cubic means it's I multiplied by I squared, which is just I multiplied by -1, which is -I. Then how about the I to the power of 4? The I to the power of 4 is the same as I to the power of 2 multiplied by I to the power of 2, which is just the I squared, it's -1, and the I squared. So this will just give us 1. And how about I to the power of 5? I to the power of 5, it's I to the power of 1, multiplied by I to the power of 4. And we know that I to the power of 4 is just 1. So it means this will give us I. So how about I to the power of 6? I to the power of 6 would be, okay, let me just. So the I to the exponent of 6, this is the same as I to the power of 2, everything to the power of 3. And what is I to the power of 2? I to the power of 2, it's -1. And -1 to the power of 3, and this will give us -1. So it's very important for you to know that. It's very, 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 very important for you to know that. Then now, again, how about I to the power of 7? I to the power of 7, it's I multiplied by I to the exponent of 6, which is just I to the power -1, which is just -I. So it's very important for you to be able to know this, ladies and gentlemen. Ladies and gentlemen, this is very important. Right, let's now move on to the issue of additions and subtractions of complex numbers that are in rectangular form. Either we are adding or we are subtracting. So there's something that we need to understand here. When you have two complex numbers that are in rectangular form, their addition, when we are dealing with addition. So for example, if we have the following, let's say we have the following. We are given Z1, let's say Z1 is A plus BI, and we also have Z2, it's A, let's say A, S, not necessarily A, let's say it's C plus DI. So if we want to deal with addition, so it means, what does this mean? It means when we take Z1, we are adding with Z2. So what we'll have, we're going to have the A plus the BI plus the C plus the di. We know very well that since here we are adding one part of this is the real one, this is the real, and this is the imaginary. And same applies, this is the real, and this is the imaginary. So which means we can still expand this expression and say, this is the same as A plus BJ, we remove the brackets, C plus the DI. So which means we can group the like terms. We can group like terms by combining the real with the real and the imaginary with the imaginary. So it means this will be the A plus the C plus into the BI plus the DI. So this will give us A plus C plus, as a common factor, this will give us B plus D into I. You see that now this is the real part and this is the imaginary. So it means when we are adding, we can just combine the real parts and the imaginary parts together. Same applies when you are subtracting. Same applies if we're just subtracting. It will just a minus there, and that will also be a minus. That is what you need. So you will just group the like terms. We just group there like terms. Then this is the context of doing the addition or subtraction. But how about if we are just doing the multiplication? Imagine we want to multiply complex numbers. So it means when we have Z1, we multiply by Z2. So this means will be, this is actually multiplications of complex numbers that are in rectangular form. So we have the A plus the BI together with the C plus the DI. So we know that this has to do with the binomial by binomial multiplication. Like when we have X plus 2 together with X minus 3, we can use the FOIL X by X. So we do the same. So this will be A times C. This will become AC plus the A times the D. This becomes the ADI plus the B times the C. This becomes the CBI. The last one is the B multiplied by the D with the I. So this will be the B DI squared. But we know that since the I is the square root of -1, how about I squared? I squared means it will be the root of -1 squared. This will just give us the -1. So which means now we can say we have the AC plus the ADI plus the CBI plus the BD into -1. So which means this will give us AC, we group the like terms, plus ADI plus the CBI, then minus the BD here. You see now that since we have simplified, this is no longer a real, it's no longer an imaginary, it's now the real. So we need to group the real parts together. So it means the final answer now would be, we are now combining AC with BD, and this one also will have to take common factor. So this will be the AD plus the CB equals to I. So which means now this is the real value and this is the imaginary value. Okay, now guys, continue with the solving of complex number. But I think before we start solving the complex number, since we already mentioned the issue of addition of complex numbers, I'll address this, and also the subtraction of complex numbers, the multiplication of complex numbers. Right, before we move on to the last part, which is the division of complex number, I wanted to address something called the conjugate of a complex number. Let's now talk about what we mean by a conjugate of a complex number. Conjugate of a complex number. All right. The conjugate of a complex number is the complex number or the complex number resulted after reflecting resulted after reflection about the real axis. So if we have a complex number, for example, if we have z equals to a plus bi, let's assume this is in the first, yes, it is in the first quadrant. So this is the imaginary and this is the real axis. So already we know this is the a. The a is the real value. Then the b is the imaginary. So we have something like this. So if we have something like this is the z. If we take this z, we reflect it about the real axis. So it means reflection about the real axis means we are referring to this axis. So it means the new equation now will the a will not change. What is going to change actually will be the b. So it means the value of b will now change. So it means if we are having a positive b, now it will become a negative b. So it means whatever we're going to get now, this will be the conjugate. This is the conjugate of z. So, and the conjugate is actually represented by a z with this line here. This is called a conjugate of this complex number. So it means the only difference between this is that if we have the z, which is a plus bi, so if we want its conjugate, we just change this sign here. So it means the conjugate will now be equals to a minus bi. So it means it is the complex number that resulted after we have done reflection about the real axis. So which if we were to talk about in terms of the x-axis and the y, then this will be the reflection about the x-axis. So which means it's not going to change the value of a. What is going to change is the b. So if if we have a plus, then this will become a minus. So this is called a conjugate, and it's represented by this z with this horizontal line. This shows that this is a conjugate of that complex number. So why do I want to talk about conjugate before we start talking? We start focusing on the division. Let me do one example here. Consider the following complex number. Let's just call it W or Z. Let's just call it Z1. I want us to perform multiplication on the complex number and its conjugate and check what is it that you are going to get at the end. So now, if we do this, we have, let's say we have Z equals to 3 plus 4i. And within this, we also take its conjugate. Obviously, the conjugate will not change. It will change the b value. So this will be 3 minus 4i. Let's try to multiply these two. So this will be 3 plus 4i and 3 minus 4i. I apologize. All right, then now we'll have to multiply these two. So this will become 3 by 3, which will be 9 minus 12i plus 12i, then minus 16 into I squared. And now look what is going to happen here. This would be 9, and this 2 will become 0. So will result with 9 minus into 16i squared. And we know very well that the I is equals the root of minus 1, which means the I squared will be negative 1. So it means this will be 9 minus 16 into negative 1, which will just become 9 plus 16, which is just 21. So what is it that you have realized here? When we use a complex number and its conjugate, once we multiply them, the answer will always become a real value. It will be a real number. We'll no longer have an imaginary, because the imaginary now is 0. 0 i's, it's not there. So it means now when we take any complex number and we multiply by its conjugate, then their multiplication will always be a real number. All the time, it will be a real number. But if we are just multiplying complex numbers where they are not conjugate to each other, then the final answer will give you a real part and the imaginary part. So this is one of the things that you need to actually know when you are dealing with division of complex numbers. We are going to talk about this. So now, it means now, since you are now able to understand how to determine the conjugate of a complex number, I want us to talk about the division of complex numbers, because now you are following. Let's say we have the following. We are told that we need to divide two complex numbers. Obvious, when we are dividing two complex numbers, so let's say we have Z1. Z1 is the a plus the bi, and Z2, it is the, let's say it is the, is this an example? Let's say it's the c plus di. So if we take Z1, we divide by Z2. This will be a plus bi divided by c plus di. Remember, the main aim of simplifying this is we want to end up having a single complex number that is in the form of a plus bi. So it means all the time when you are dealing with the division of complex numbers that are in rectangular form, it's either we convert this to polar or we work them in rectangular form. Okay, I apologize. It's either we change them to polar or we just work them in rectangular. But if you want to get the answer in rectangular form, all the time we do this. We have to look at the denominator, ladies and gentlemen. We know that when we take a complex and we multiply by its conjugate, the value always become a real value. So it means all the time the denominator, we need to make sure that the denominator gives us a real value. And to do that means we need to multiply by the conjugate of this denominator. And by so doing, it means now we are going to do this. Remember, if you are multiplying here, it means we have to put the conjugate of this, which is c minus di. So obviously, it means even there you must put c minus di. So because this is actual 1. So let's now work this out. This will be z1 over z2 equals to a plus bi. We are multiplying the numerator together with c minus di. Same applies, the denominator, we have c plus di. We multiply by its conjugate, which is c minus di. That's why if we simplify this, the answer will always become real. Why? Because when you multiply these two, it will be c squared minus cd plus cd, which will be 0. The negative this, you see, it's going to give us a real number. So all the time when you are dealing with division of complex numbers that are in rectangular form, you need to always consider the denominator. And at the denominator, you need to multiply by the conjugate of that denominator. It's very, 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 very important. So number one, we went through the addition. I've addressed that. 2, subtraction. 3, it's multiplication. Then 4 is the issue of complex, I'm saying the conjugate of complex number. 5 is division. So it means we use conjugate of complex number to deal with division, unless if we convert these to polar form, which will be addressed in the next session. All right, I want us to go through the problem solving. I want us to solve problems relating to what we have done already. There is a tutorial that is actually shared here. So I want us to go through this, ladies and gentlemen. Okay? All right, let's now continue. Okay, right. Let's now go through the tutorial. Then the question says, evaluate the expression and write your answer in the form of a plus bi. We need to evaluate this expression and write the answer in the form of a plus bi. Just a minute, guys. I just want to copy this question first so that we can be able to solve them somewhere. Okay. Then now, okay, let me just plug them here because I want to solve them. Okay, that's fine. Right, the first one says, evaluate the expression and write your answer in the form of a plus bi. So it means we want them to be in a rectangular form. Let's look at the first one. The first one, we have 5 minus 6i plus 3 plus. So we're just adding two complex numbers. Here we're just subtracting two complex numbers. These are just multiplication. Let's start with the first one. Obvious, the first one, or I can even copy it here. So we have in brackets, we have 5 minus 6i plus 3 plus 2i. Let's now remove the brackets. This will be 5 minus 6i plus 3 plus 2i. So we can write this in a standard form by grouping the like terms. So we have 5 plus 3, this gives us 8. And minus 6i plus 2, this gives us minus 4i. So you can easily see that this is in the form of a plus bi. And if we wanted to draw this in an argand diagram, the a will be 4, I'm saying it will be 8, then the b will be minus 4. So it means it will be in the fourth quadrant. So it means the angle will be represented in this form. But it's not what we're looking for now. So we got the answer. Right, the second one, what do we have? The second one, it's 4. We're still subtracting. We remove the brackets here. So this will be 4 minus half I minus 9. Then we multiply by negative, is negative 5 over 2i. And this will actually, then we group the real with the real, the imaginary with the imaginary numbers. So obvious, the real numbers is 4 and negative 9. 4 minus 9, this will be minus 5. Then now minus half and minus 5 over 2, this will give us minus 3i. And this actually, it is in the third quadrant, if we were to use an argand diagram. Remember, this is the real, this is the imaginary. The 8 is negative 5. and the b is -3. So there will be in the third quadrant. So now we move on. Let's now move on. So the next one is the issue of multiplication. We can do the multiplication. Let's do the multiplication. Here we are multiplying 2 plus 5i multiplied by 4 minus I. So 2 plus 5i multiplied by 4 minus I. So that is number 3. So it's 2 plus 5i multiplied by 4 minus I. Let's remove the brackets. 2 times 4 is 8. Positive 2 times I, this is negative 2i plus 20i minus 5i squared. And we know that the I squared is equals to -1 because the I is the root of -1. So which means if we make I squared, the answer will be -1. So, but now this would be 8. These are like terms. Minus 2 plus 18 plus 20, this will give us plus 18i. I apologize. Then minus 5 into I squared is -1. So this will give us 8 plus 18i plus 5. Let's write this in a standard form. Obvious, this will become 13 plus 18i. Obvious, this is in the first quadrant. This is in the first quadrant. Then number 4, what are we given? Number 4, it's 1 minus 2i multiplied with 8 minus 3i. Let's remove the brackets. 1 multiplied by 8 is 8. Minus 1 multiplied by -3i is -3i. Then -16i. Then plus 6i squared, if I'm not mistaken. And by grouping like terms, this will be 8 minus, these are the like terms, minus 3 minus 16 is minus 19i. Plus 16 into I squared is -1. So this will become 8 minus 19i. We multiply by negative, this will be -16. So the final answer will be, we group the real with the real, imaginary with the imaginary, this will be -8, -19i. And -8, -19 will be in the fourth quadrant, in the third quadrant, I apologize. So I believe you are following. I believe you are following. Right, now let's move on to the next questions. We went through number 1, 2, 3, and 4. Then now let's look at this. Number 5, what is number 5? Number 5, it is the conjugate. We want the conjugate of this complex number because there's a line here. This represents a conjugate of this. So it's straightforward. So the conjugate of this will just be 12 minus 7i. So we always change the b value because it's a reflection about the real axis. So that is the conjugate. Same applies with this. We need the conjugate, but before we simplify the conjugate, before we give the conjugate, we need to simplify this expression by removing the brackets. Let's multiply by I. 2i multiplied by half, this will become I. Minus 2i multiplied by -i, this is -2i squared. Let's simplify this. This is going to be 1 minus 2, no, I'm saying the I minus 2 into, it's 2 into, remember I squared is -1. So it means this will give us I plus of 2. But let's write this to be in a standard form because it's not in a standard form. It started with the I instead of starting with the A. So it means when we rearrange this will be 2 plus I because the conjugate, we do it on the I, not on the real number. So it means the answer there will be 2 minus I. I believe you are following. I believe you are following. This is called conjugate. This is the symbol for the conjugate. Okay, let's now look on the ones that are in when we're dividing. Division of complex numbers. Okay, right. Let's start with the first one. What do we have? 1 plus 4i. 1 plus 4i divide by 3 plus 2i. 1 plus 4i divided by 3 plus 2i. And 1 plus 4i divided by 3 plus 2i. Let me write it here. 1 plus 4i divided by 3 plus 2i. This is division of complex numbers that are in rectangular form. Number one, we need to make sure that we look at the conjugate of this, the denominator, the conjugate of this the denominator. And to do that means you're going to do this. We're going to say we have 1 plus 4i, open brackets. Then same applies this side, 3 plus 2i. Then now here we're going to put the conjugate of this, which is just 3 minus 2i. And we do the same here. 3 minus 2i. So always you consider the conjugate of the denominator. So let's now simplify. This is just multiplication. Let's multiply. 1 multiplied by 3 is 3. 1 multiplied by negative 2i is negative 2i plus 12i, then minus 8i squared. Let's do the same at the denominator. Remember, this must always give us a real value only, the real part only. So let's do the multiplication. This will be 9 minus 6i plus 6i minus 4i squared. So this would be, let's simplify the numerator. Going to have 3. These are the like terms. Minus 2i plus 12, this will give us 10i. Minus 8, we know I squared equals to negative 1. So it means we're going to put negative 1 here, divide by, then obvious, the denominator, this will be 0. So we're going to remain with 9 minus 4 into I squared is negative 1. So it means this will give us 3 plus 10i plus 8 divided by 9 plus 4, which is just 13. Let's now rearrange this to be in a standard form. We want it to be a plus bi. So let's rearrange, then 8 plus 3, this gives us 11 plus 10i divided by 13. Remember, the reason we multiply by the conjugate, we want the denominator to be a real value. So then now, to do this, we're going to divide everything by 13. So it's going to be 11 out of 13 plus 10 out of 13i. It's now in a standard form of a plus bi. A plus bi. I believe you are following. I believe you are following. Always, unless if we convert this to be in a polar form. It's very, 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 very important. And what is the next one? Okay. Okay, then we'll move on to the next one. Okay, let me check the next question. The next question is 3 plus 2i divided by 1 minus 4i. 3 plus 2i divided by 1 minus 4i. Okay, we have 3 plus 2i divided by 1 minus 4i. Same applies. 3 plus 2i, open, close, then 1 minus 4i. Then here we multiply by the conjugate and make sure that is written in the form of a plus bi. Must be a first, then b, then this will be 1 plus 4i. Same applies, 1 plus 4i. Let's do the simplification. Then this becomes 3 plus 12i plus 2i plus the 8i squared, divide by, let's do the simple, let's simplify the denominator. This is 1 plus 4i minus 4i minus 4i squared. And this would be 3 plus 12i, grouping the like terms, plus 8 into, I squared is minus 1. Divide this, then this becomes 0. So we're going to have 1 minus 4 into negative 1, because I squared is 1. So let's group this. This will be 3 plus 12i minus 8 divided by 5, because this is 5. And then let's simplify this. Let's now rearrange this. These are like terms. 3 minus 8 is minus 5 plus 12i divided by 5. Let's divide everything by 5. So it's minus 5 divided by 5 plus 12 divided by 5i. So it means the final answer would be minus 1 plus 12 over 5i. You see, it is in the form of a plus bi. Very important, very important. Okay, right. Let's now move on to the next question. Okay, I think you have done, there's something wrong here. This is not the answer. Yeah, I can feel it because I can see that I have multiplied by the last term here. Okay, something wrong here. I apologize, guys. So here, actually here, this becomes 16. It should be 16, not 4. Okay, because 4 and 4, this becomes 16. So it means I need to check the work. Okay, 16 here. So it means this would be 17. So this will be 17 here. So it means we have to change this to be 17. So we divide by 17, not by 5. So it means this will be the final answer actually. So by 17, no, not by 5. I apologize, guys. This one. Okay. Plus 4 minus 4 minus 16. Okay, fine. So this is the answer. This is the answer. Okay, let's now move on. Right, next question. What do you have? We're just dividing, so it means I believe you can do number 9 and number 10. You do the same as what I have indicated there. Then let's move on to number 11. Number 11, we have I to the power of 3. In terms of exponent, this is the same as I multiplied by I to the power of 2. Because when the base are the same, we take one base and we add the exponents. So it's I multiplied by I squared. And to do this, it means we know that I squared is equals to negative 1. So the I squared is equals to negative 1. This is I multiplied by I squared. So we know that I squared is negative 1. So if you plug here, this will be I multiplied by negative 1, which will just be negative I. So now let's look at this. This is I to the power of 100. And 100 is an even number, which means you're going to say this is the same as I squared to the power of 50. It was 50 times 2, it's 100. And now, what is I squared? I squared, it's -1. So what is -1 to the power of 50? Obviously, the answer would be 1. Obviously, the answer would be 1. But now, how about if we have I to the power 121? It's just an example. Obviously, 121 is an odd number, which means it's the same as I multiplied by I to the power of 120. Because we want to use an even number, it becomes easier because 2 multiplied by 60 is 120. So it means that now we're going to have I multiplied by, this is I squared to the power of 60. So you see that 6 times 2, it's 120. So it means this will become I multiplied by, what is the I squared? I squared is -1. And you know that -1 to the power of 60, it will still give me 1. So if it's giving me 1, it means 1 multiplied by I, then the answer becomes I. So it's very important to understand this complex number. Remember, I've extracted these questions from the James Stewart textbook, the calculus one, the university one, but the application is the same. Then how about this one, number 13? Number 13, it says the root of -25. Obvious, this is the same as the root of 25 multiplied by the root of -1. And what is the square root of 25? It's 5. And we know the square root of -1 is just I. So it means the answer is it's 5I. Then how about this? The root of -3. The root of -3 multiplied by the root of -12. The root of -3 multiplied by the root of -12. Same application. So it means this is the same as root of -3 times the root of -12. This will be root of 3 times the root of -1 times root of 12 times the root of -1. And we know that the root of -1 is I. So it means this is the root of 3I. And we know root of 12. Remember, 12 is the same as 4 times 3, which is the same as 2 root 3. 2 the root of 3. So we'll have 2 root 3, then this is the I. So we can multiply these two. Root 3 times root 3 is 3. This will become 6. I times I, it's I squared. Then we're going to have what? 6 times, what is I squared? We know that I squared, it's -1. So we're going to have -1. So it means the final answer will be -6. So the answer is -6. So it's very, 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 very important to be able to understand these questions, ladies and gentlemen. For example, sometimes in the exam, they can say, determine the root, like what I've done initially, to say, find the root of an expression, like what I have done of x squared plus x plus 1 equals to 0. So we can still use complex numbers. So in summary, we went through the standard form of a rectangular form of complex number, which is a plus bi, the a being the real part and the I being the imaginary. No, I'm saying the B being the imaginary part. And we know that this I is the square root of -1. And we can represent this in an Argand diagram. And we know that on an Argand diagram, the x-axis is the real part. The y-axis is the imaginary. And we went through the addition, the subtraction, and the multiplication of complex numbers. And again, we went through the conjugate. How to determine the conjugate of a complex number that is in a rectangular form. Obviously, we do the reflection about the real axis. So it means the A is not going to change. So if we have A equals to Z equals to A plus BI or J, so it means each conjugate will be A minus BI. Same applies. We went through the division of complex numbers, but when you are simplifying complex numbers where you are dividing, you need to always use the conjugate of the denominator. Very important. Like, for example, if you look at number 10, the one that I said you must go, it means this one should be 4 plus 3i. Same applies 4 plus 3i because we do the conjugate of the denominator. So I will also solve problems. Maybe I will take one paper from the NCV, maybe level 3 or level 4, or even the nated one, the N3 or the N4. It depends on the questions where they've asked this. So these things are very important. And actually, to be honest, guys, complex numbers are widely used in the field of financial maths and also in the field of engineering. Let me just say in the field of engineering, particularly under the concept of electricity and electronics. So it's very important where you're talking about the impedance, where you are determining the impedance, and the reluctance. So it's very important for you to understand complex numbers, both for university and also for the TVET college. Thank you very much for listening, guys. Hope to see you in part 2 of the complex numbers. Don't forget to like, subscribe, and hit the bell button. Bye-bye.